Students, so in this video we are looking at another algorithm concerning the products and the quotients, and then we are beginning with the product rule. We are beginning with the product rule. So if I have two functions u, if I have two functions u and v, and these are differentiable functions of x, these guys are differentiable functions of x, if they are differentiable in x, or differentiable functions of x, if they are differentiable functions of x, or if they are differentiable with respect to x, their product u and v is also differentiable. In other words, the dx of their product also exists. But what does the product rule say? The product rule says you first leave one constant, differentiate the other, plus leaving the other constant, differentiating the former. So in other words, it is u differentiate the second thing with respect to x, dv dx, plus v differentiate the first one, du dx. That is simply what we call this is simply what we call the product rule. And then the proof I can leave for you guys, like a simple proof. Yeah, the proof, we will look at it and then appreciate it. So if we are to do some example, so as a part of our example, I have y that is equal to this. We want to differentiate this. So instead of expanding this guy, yeah, you can choose to expand it, but some functions are very long, as we shall see, and you cannot easily expand them. So you simply use the product rule. So we have this guy times this guy. So if we let our u to equal to 3x plus 2, and then we still let our v to equal to a 7x plus a 5, such that now from the dx of u times v, which is equal to u dv dx plus v du plus v du dx. So my dv dx differentiating this guy with respect to x gives me a 7, and then my du dx differentiating this guy with respect to x gives me a 3, because the x goes, and then the constant, when I differentiate it goes to 0, such that in other words, simply my dy dx will equal to, give me a u is 3x plus 2, give me a dv dx, this guy is 7, plus give me a v is 7x plus 5, then give me du dx, which is a 3. This guy is the same as 7 times this guy is 21x plus a 14, then plus, then 3 times this guy is here 28, hopefully. 7 times that guy is this is 7, oh, this is 3, this is 3, I still see a 21, I still see a 21x, and then plus 3 times that guy, which is a 15, such that I have a 21 plus a 21, I think it goes to a 42. This guy goes to a 42x, then 14 and 15, I think they give me a 29, and it is as simple as that. So we have our next example that differentiate that guy. So I can begin by letting, I can let my y to be that function of x, which is 3x power 4 plus 2, then raised to power 8 into 5x squared plus 7x power 3, such that if I let this guy, still if I let that one, then if I let u to equal to a 3x power 4 plus 2 raised to power 8, and I still let my v to equal to a 5x squared, my v can equal to a 5x squared plus 7x power 3, such that I know that from the d with respect to x of u times v, which is given by keep u constant, give me dv dx then plus keeping v constant give me du dx, such that I know my dv now, dv dx. You can do direct differentiation on this, or you can use the chain rule. So direct differentiation, what will it say? So lower down the power, it will say lower down the power lower down the power, which is going to be an 8, then differentiate what is inside the brackets. Lower down the power, which is an 8, differentiate what is inside the brackets, which is going to be, when I differentiate this gate, is a 12x cubed, then into keep the bracket now 3x power 4 plus 2, then reduce the power by 1. This is lower down the power, differentiate what is in the brackets, keep the bracket, and then reduce the power by 1, which is going to be a 7. Yeah, so you have there an 8 times 12, 8 times 12, 8 times 12, that is 96. So guy becomes hopefully 96x cubed into 3x power 4 plus 2 raised to power 7. Then I can have there the du dx, dx, the differentiation of u with respect to x, differentiating u with respect to x. Let me see, I had let this guy to be u, this is du, yeah, this one was du dx, so this one is dv dx, yeah, the curve is the other small one. So dv dx, the same thing, the same algorithm, such that this one lower down the power, which is going to be 3, multiplied by, differentiate me what is inside the bracket here, which is going to be, if I differentiate this guy, I see a 10, x, then differentiating the 7x plus 7 plus 7, then give me the bracket, reduce its power by 1. This is going to be 5x squared plus 7x, then reducing its power by 1, this guy is squared, such that now generally my dy dx, which is equal to, now give me a u is a 3x power 4 plus 2, this guy is raised to power 8. So this is the u, then dv dx is the whole of this guy, which if I make this guy enter here, it is the same as a 30x plus 21 into a 5x squared plus 7x squared, then plus now give me a v, a v is the other guy, which is going to be a 5x squared plus a 7x, this is squared, this is a plus a 7x squared, and then we are multiplying it by du dx, multiplying it here by du dx here. If I put it here down, du dx, and my du dx is this guy 96, this guy is the same as 96 x cubed, open brackets, 3x power 4 plus 2 raised to power 7. You may not die expanding these guys and create a single expression. You can chill it to that level. Yeah, you can chill it to that level. Yeah, so in our next video, let's handle the quotient rule. Let's see how we use or we apply the quotient rule. It is also a very simple algorithm.